now we have loaded the classifiers, we have loaded the training and the testing, the splitting functions and the classifier names. Okay. Now what is the most important thing? We need to load the data set. So I'm taking the variable as iris equal datasets dot load function of iris data. So this is an inbuilt function which will be loaded from the classifiers. Okay. So once this data has been loaded, so you need to apply the function. What are the things that we need to train? So I need to check the value of x value, training value and testing value of x. Similarly, y training and y testing equal to train underscore test function. So this is a function. So train underscore test underscore split of what is the data set iris dot data, comma, what is the value I need to get? I need to get the accuracy value. So that is my target function. So I'll be calling another argument as iris dot target. Okay, based on the target value. So the target values are represented in 0, 1 values, 0, 1 and 2, where 0 stands for the value versicular and 1 for virginica and 2 for setosa. Okay, so that can be loaded using your confusion matrix. Okay, whereas in your lab program they have not mentioned regarding the classification matrix, so I have skipped here. Okay, if you want that, click on print function, print the confusion matrix using the dataset iris. Okay, so once this has been loaded, so based on the neighbor functions, we will be writing the value of k, right? So the value of k will be given from 1 to any number. Okay, it depends on the separation of the dataset values, whether it is positive, negative, like that. Here the dataset is split into 3 values now. Okay, so let us see the first one. Let us assume the value of k is 1. Okay, suppose if I'm having 100 instances, so I'll be having 100 k values here. Okay, so based on that I will be differentiating it by 1. Okay, then once the model has been designed, so I need to fit that data. Okay, so model dot fit of what are the values, only training value has to be considered. So I'll be taking x train comma y train. Then I'll be predicting the score of the value, so model dot score. Then once I got the value of the score value for the given iris data set, I'll be loading the matrix dot accuracy underscore score. So this is an inbuilt function which will be present in the matrix of what is the condition that I need to check. I need to check the, as we already loaded the data set with train for x and y, I need to check only the testing phase values. So for that, the prediction value is represented by y underscore test, and the data will be loaded in the model dot predict function of x underscore test. Okay, so let us run there. So when I run this, we are getting the output as 94% for when the value of neighbor function is 1, equal to 1. Suppose if I change it to 2, so we are considering 2 instances at a time. So when I run this, we are getting slightly variation, that is 0.9473. Okay, suppose if I take the value of k as 3, let us load it once again. When I run this for the value k, you can see here, when I run the k value for 3, I'm getting the highest accuracy now. It is getting 97%. It's represented in decimal values. When we convert it, we will be getting it into 97%. Suppose similarly, if I load the value for k equal to 7, so if I run this, you can see here when the value of data set k value is 7, the accuracy is of the range 100% accuracy. Okay, if I load it by more than like 15, k value is 15, you can see here it's getting changed. Okay, for particular value, you'll be getting a accuracy value that is nearer to the 100% value. Okay, so this is your 9th lab program. Okay, I'll be sending one more lab program where you can get the accuracy matrix and you can know the what are the actual data sets of the iris data sets for 3 different categories. Okay, you can use any one of the lab program. Okay, any doubt in this 9th lab program, if you have, you can ask me. So here the first 4 are the inbuilt functions we are reading from the library, from the scikit-learn library, and loading the data set, and this is my model training, and this is my fit training, and this is my prediction value. Okay, so this is about the 9th lab program. Okay, So let us go with some other example of using Gaussian algorithm. We have studied Navy Bayes, right? So in the fourth module, we had studied the Navy Bayes concept and we had not done any problems on that. So today we are going to do one problem on Navy Bayes. Okay. So I hope you can see the screen. Here we are getting the CSVs and we are reading pandas library, numpy library, as well as scikit-learn. You can see here scikit-learn dot Navy Bayes. We have taken the algorithm as Navy Bayes algorithm. From that we are reading the Gaussian Navy Bayes. We have two different categories of Navy Bayes. One is normal Navy Bayes, the other one is Gaussian Navy Bayes algorithm. Okay. So once this data has been imported or the libraries has been imported, so I need to read the data set. So to read the data set, data equal to, we are using pandas dot function read underscore CSV and the file is Pima underscore Indian underscore diabetes. So we are reading the diabetes function file. So you can see here in the diabetes prediction, we have 9 labels based on the pregnancy, based on the glucose level, based on the blood pressure, skin thickness, insulin values, and body mass index, diabetic range values, and what is the actual age of that person, and what is the outcome. So here the value of the outcome values are 1 and 0, like my target values. Okay, if it is 0 means he is not going to get any diabetes. If the value gets 1 means he is going to get diabetes based on the values that will be fed through the file. Okay, so that is given by in this function. So what I am doing, I am taking a value of x as array value using iLocation, which we have studied in the first basic concept. What is iLocation does? It gives the index location of the respective files. So we have taken all the values and we are excluding the target value here for x. Whereas in the second one, we are considering all the details and we are excluding the target column, that is my last value. Last column, that is my outcome label. Okay. So once it is done, I'm printing the data of the sets, only the head part, that is for the first 5 consecutive rows values will be printed. Then, so this is the first concept of loading the data set and what are the actual training purpose we require. Now I need to load the model function. So model equal to Gaussian NB. So directly I'm reading the Navy Bayes function and I'm fitting the values for x and y using model.fit. Then for predicted value, I need to get the actual prediction, right? Whether it has 1 or 0. So I'm reading it through file by giving the values. So it's equal to model.predict of. So we had 9 different labels for the data set. So hence I have given the 9 different values for the testing function now. Okay. Then once the value of the prediction is got, so what we will do, we print that value here. Okay. So let us run this. You can see here when I run the value, it's showing the predicted value is 1. So it's printing the first 5 rows and it's printing the value 1. Suppose if I change the value here like 54 instead of 54, let me give 32 as the age value. So if I run this, for 32 also you are getting 1. So let us go with some other changes here. 20 and the age factor is 18. So you can see here when I run this, I am getting the prediction that it is 0. So for all the values, and if the age value is 18, okay, so he is not going to get any diabetic function. Okay, so this is simple example of using a Navy Bayes algorithm. Okay, using the inbuilt functions. Whereas you can use the concept of functions also. Okay, when you write the concept of functions, the program will be very lengthy. Okay, you can use directly the inbuilt functions for the particular programs. Okay, if you have any doubts in this, you can ask me, or we will be directly going for the next theoretical concept. Okay, any doubt? Okay, so this is about your 9th lab program, K nearest neighbor, and one simple example using Navy Bayes algorithm. And okay, Next, we have the theoretical concept. This is my second chapter.